Hello, everybody. While we get the microphone straightened out, I thought I would start since everybody's time is valuable. This is a session on problem solving in the age of microservices. I am your host, Moshe Yudkowsky. This is Thomas Howe and Mr. David Casem. This is going to be a cross between an interview, a panel, and an AA session for data addicts. And I think that's probably the best way to phrase it. I happen to be a data addict. I live and die by data. I run something like 40 reports every morning. Anyway, my name is Moshe. I am a consultant in speech technology. I just want to give you a brief insight into what's going on. When I created a system, and I'm working for a company, and you've got a telco platform, and you've got your telco servers that feed data into it, and it's pretty complex because every single step in the process requires some sort of back-end computing, so it goes back and forth. Now I'm going to tell you something about speech technology. When you have speech technology, if I ask you, if you talk to the machine and you hesitate for just a moment in the response, right? I say something, how long does it take for the machine to respond back to me? Now, it can take 2 days, right? But if you take more than about 500 milliseconds, half a second, what was that? Oh. What will happen is the person thinks you didn't respond, you didn't hear them, you have to say it again, and that can create a lot of confusion. And that's actually true, not even for speech. That's even true if you're hitting touch tones to do your input. And so when I first got this system, the response time was miserable for some particular interactions, and I spent about a year working with the other guys. I was doing this piece, I was doing a little bit of that piece, they were doing the other piece, right? And working with them for a whole year, and right now we're running the system 7 years later, still the same system, and the average response time is 1/4 of a second, and that includes travel time between a box in Orlando getting messages from a box in San Francisco, right? So that's pretty darn good. How did I get there? By being a data addict. Great. Now the problem is the next generation of systems are going to be built out of elements that are even more diffuse. I don't know if you I can't even track how many elements. I'm going to have a server here, and I'm going to have a server up in the Amazon cloud, and I'm going to have a different server in the Amazon cloud that does something else, and I'm going to have a database over there from some other thing, and I'm going to have maybe Twilio, send messages to Twilio, and now I'm going to have all these pieces talking to each other. So first of all, I'm concerned about how fast they're going to speak to each other. Thank you very much. And the second thing I'm disturbed about is how am I going to get all the data into one place, or at least a couple of places, so when I'm trying to correlate all those various things that are moving parts, how am I going to get them all to work together in an age of microservices? Since I'm lazy, I decided to get some people to show up and tell me how to do it. And these people are Mr. Thomas Howe and Mr. David Casem. Now, I'm going to introduce Mr. Howe first to make an opening statement. It's sort of a statement for the, he's pleading to the audience, right? Sort of your plea bargaining agreement, right? Sure. Thomas and I used to actually do a sort of road show. He would call me up and say, hey, Moshe, I want you to come and give a talk somewhere. And the one that I enjoyed the most would be sort of the first version of this talk, which was how to build these kind of distributed systems in the first place several years ago. And now I'm going to ask, so let me give you a few moments about Mr. Howe, 27 years in the telecom industry, first products in video conferencing, ADSL, VoIP, internet communications, messaging automation, 2015 TAD Hack Global Competition, O'Reilly Mashup Competition, Von Innovators Award, University of Massachusetts, Northeastern University, and studying both digital signal processing and abstract mathematics. Sir, your statement.
Thank you.
Please use the microphone for the non-lip readers in the audience.
Good morning, afternoon. We're pretty close. Thanks for having me. My name is Thomas. Let me tell you what interests me about this and what should interest you as well. So back when I was younger, and a lot of us were younger, putting systems together was pretty simple because they were siloed. A voice thing was only a voice thing. only connected to voice things. And today that's clearly not true, and accelerated by the fact that we've got smartphones in our hands. Because the smartphones can not only generate voice, because that's kind of why we're here, but they can also generate other things like messaging and videos and data, both to generate data and to consume it. And so all the use cases that we have in business have jumped from siloed things to very interconnected things. And so as we interconnect all of these various systems, some are real time, like Moshe said, some are instantly need to be there, like video and voice, and some take their fine time, like searching a database for customer information. So as you go through your professional careers, either as a business person or as a technologist, what you're going to find increasingly is that your scope is going to be much wider, and that wider scope is going to imply a real challenge in getting these systems to work, either as a person who has to make them work, or as someone who has to figure out who can make them work. And hopefully after this conversation, you'll have a little bit of an idea about both. So, thank you.
Thank you very much, sir. Now I will introduce Mr. David Casem, who's the CEO of Telnyx, and I found him not because I know the gentleman personally, even though we have offices in the same city, but because I asked Thomas Howe, I need to find somebody clever to be another panelist, and he nominated Mr. Casem. And I trust Mr. Howe. I realize that Mr. Howe is shaking his head. Why would I do that? He is a self-taught engineer and entrepreneur. David built the first iteration of a phone company using open source software, a few relationships, and a license from the FCC. Telnyx is now a global software-defined telco whose problem domain includes identifying the best submarine cables to interconnect continents and to understanding international regulatory systems to arbitrage wireless spectrum. He serves on any number of excellent organizations. I hope you don't mind if I read them all. And I look forward now to the gentleman perhaps giving us a brief statement on this topic.
Sure. Telnyx really sort of addressed this problem from a software perspective. Today, unlike the times of the past, folks have really decided to pursue computer telephony integration as sort of a first-class citizen in terms of how they build their infrastructure. And so, some of the things that we hope to bring to the conversation here are around how do you integrate with systems now that traverse multiple cloud providers, right? Not everyone is using AWS anymore. Folks have chosen to use Azure or Google Cloud. How do you deal with the problem of different regions of the world requiring access to the same services? In things that relate to speech tech, you have low latency applications that have to be able to respond quickly to the customer, as Moshe pointed out. So how do you design systems that are going to be able to work in those sort of environments? I think the other thing that we're hoping to help folks tackle is how do you prevent yourself from getting locked in to these systems too? As you sort of take this microservices approach, which from an architectural standpoint means you have to figure out distributed tracing, figure out when you initiate a request, how that touches different systems. We'll sort of hopefully be able to speak to that. And then in addition, what do those interactions look like with third parties? So as you rely on Amazon Poly, for example, or you want to put yourself in a position to use Google Wave in addition to that, how do you build your systems such that you have clean interfaces that allow you to use multiple vendors so you don't get yourself stuck in a situation that you don't want to be in and then are looking for a migration path? So I think that looking forward to the conversation and addressing some of those concerns.
Excellent. Thank you very much. Now I'm going to put up gobbledygook on the screen, okay? I have a couple of things of gobbledygook to put up here. This is the first piece of gobbledygook. Let's see if it gobbledygooks up there. Terrific. Wonderful. So I'm debugging a problem where...
Dude, that's gobbledygook.
Pardon me?
That's gobbledygook.
Isn't it wonderful? I love it. So I'm going to explain the gobbledygook you're seeing. And first let me explain the problem that I was looking at. I have a speech system and things come in through telephony, and I'm finding people are calling in, and every once in a while, I get complaints or I notice my why is this person being cut off in the middle of the call? They're 1 minute into the call exactly, and they're cut off. Or, oh, actually, no, actually, you know what? This one was better than that. This one was, they call me and say, we've got a bunch of callers, and for some reason, they're getting cut off. What's the problem? And then I go and I start doing, with these wonderful packages I have, I say, it's happening in exactly 15 minutes. And this is the problem right here. So I want to show you this search. I'm going to read this search to you. So the part in red is what I call a sub-search. It's actually, that's what Splunk calls it. Look for all SIP.2 messages that are not actually CCXML messages. I then have a little macro which does a regular expression match against those messages that I found to find what the response was. Now, I then use a if thing. It says if the SWIP response was a 491 reinvite, then select out the CTA field out of that SIP response. Okay. Then this continues and says, given only those particular items, look for SIP 2.0, look for the SIP ID, which is another regular expression, put them into a group, and then see which ones have this particular little phrase built into it. And then I print them out. And this is just part of the thing. And then afterwards I go back and say, now look for the some other messages in the system, and I find out that this particular SIP stack has an error in it. And what the error is that it's sending out a message that it shouldn't, and we get this error message called reinvite. And when we get that reinvite message, what happens? We say, oh, great, there's an error, and we drop it. That's it. Call's gone. So 15 minutes into the call, we send out the wrong message. They send back, say, you can't do that. We say, well, you can't do that either. Well, you can't do that. Well, you can't do that. That's the call's over. Now, the question to my panelists is, if I'm doing this with my system, and I don't have access to these SIP messages, let's say I'm interacting with Twilio, how am I going to even search through 5,000 messages? Because I know you can download the SIP, individual SIP messages to do what I just did, but I can't download 5,000. There's no API. I'd have to go to the web page and click on each one individually. Maybe I'm wrong. Maybe there's a way to do it. I'd love to hear about it. So, that's hard problem number one. Anybody want to say how wrong I am? Yeah, there you go.
Hopefully you'd be using Telnyx and not Twilio.
I realize that is absolutely the correct solution, but there are certain things that are out of my hand at the moment. Go ahead.
But irrespective, I think one of the ways to sort of tackle this problem, I think just to give folks some context to what Moshe was talking about here, traditionally, when you wanted to interact with the public telephone network, you had to use the SIP protocol. So the SIP is the equivalent of HTTP for the web world, and if you wanted to be able to send a phone call, you would send something called an invite, and you would interface using a SIP stack. The world has changed in that companies have realized that finding telephony engineers is difficult. There's a small universe of them, and there's a much larger universe of software developers that understand HTTP. And so they've created products that allow regular web developers who have no experience with telephony or SIP to be able to initiate phone calls, answer phone calls, play messages, listen to DTMF, pretty much any sort of IVR function that you can think of, and it can get really sophisticated. You can fork media, you can do text-to-speech, speech-to-text. If you can imagine it, it probably can be done over HTTP today. And so what we recommend that our customers do when they are interfacing with Telnyx, and what we do internally when we interface with both internal and external services, is we sort of use a service mesh concept. And the service mesh allows us to deploy a proxy element. The proxy element that we use is Envoy, which is an open source project made available by Lyft. And what that does is essentially creates a means by which every message going to and from our systems is in turn recorded. And then you can essentially pipe that out into Splunk, into Graylog, or any other system that you want. You can also use it to do things like distributed tracing. So if you have a request ID and that is then traversing multiple services in a microservices environment, you can use that. So something like Jaeger will fit nicely on top of that as well.
Okay, very good. So let me say that back to you, see if I understood. The way that the new world is that as somebody who does Ruby development will get a function that they can use that will touch Telnyx or touch Twilio or some other similar inferior service, right? And lets me do that without having to know all that 491 refer, refresher, UAS client stuff. Great, terrific, that's a great advance. And then when I, as the person trying to do debugging, try to get the data, you've put a little box between you and the rest of the world, which will send me data to me, which I can put into any service I want, and that lets me have that data. Is that a fair statement?
Close. So, I mean, we do make that data available to you. We make that data available to you via API, but what we would recommend that you do concurrently is you set up that box on your side.
Okay.
Right, so that, and ideally the vendor that you're using is providing clear response error codes and things like that. I mean, that's obviously something that you have to count on and something that you need to test for, right? Is
right.
Send a malformed request and see how that vendor in turn responds. But ultimately, the idea is, we're going to have a record on our side of what we think is happening. We'll make that available to you via API or via web portals. Similarly, as doing it via the web obviously creates issues, but ultimately, if you have a proxy element on your side, you should be able to see what's happening from a request and response standpoint.
Very good, thank you. Good, Mr. Thomas.
So just a quick audience survey, and this isn't a trick question. But so when you looked at the gobbledygook, how many of you go, I know what that is? Raise your hands. Okay, I got 3 of you. So the first thing I want to point out
so it
is...
was a bad gobbledygook.
No, this is important. No, the gobbledygook is important. So the first thing I want to point out is if you go out into the wild and outside of this particular room, that number is going down. It's going from 3 of you who know what they're doing to like bupkis. And so that becomes really important for how you would, I think, try to approach this problem. So as we've said, being a voice engineer is a weird thing to be. Aren't that many of us, right? Which is probably a good thing. When I think about that for a second. And so even as a voice engineer, I kind of knew what that said. But if you were to, give me the same example, maybe in video, I might not know that, or et cetera. So that points out 2 things I want to just communicate. The first thing is, because you're not going to be the expert at what you're going to be integrating, because hardly anybody is, the most important thing I think I'm going to emphasize is make sure that when you find a partner and find an integration partner, they give you good stuff coming out, where the actual notifications of events is clear and lets you have visibility, because you're not going to be able to see it yourself, or you don't know what it means. Even if you're a great software engineer, you won't know what it means. So as a criterion for selection and deployment, make sure your vendors and your technology partners do a really good job at spitting out what they know. That's the first thing. The second thing I want to point out is, we live in a world that's dominated today by technology that comes from the web, mostly. It's the dog. Voice and communications, it's the tail. So what this points out for me is when we're instrumenting voice systems, and this is a case where I'd call operational, network operations. Things are happening in the field. How does it happen? When you're instrumenting for it, you have to start, in my opinion, with the debugging tools available to the web guys, to those guys. That's where you start. Even though you're voice people and you're debugging a voice problem, the actual backbone of what carries all that information is probably going to be from the web side of your technology. So things like Papertrail and Loggly and all these services that allow you to capture that textual information, to be able to analyze it later. That's the backbone. So as you think about this particular problem, voice, in this case, we are the tail. And all the great technologies for capturing and analyzing all the information, it's outside of our market, and that's where you need to look for it.
Ooh, okay. Well, see, I'm very fortunate because voice, no phone calls, no revenue. That's one of the things that I work in.
Indeed. Right.
Okay, and on the other hand, yes, and now it's been expanded to video, it's been expanded to chat, and now it's expanded to
Yeah, by the way,
other media.
Yeah, by the way, shameless plug time.
Oh.
Because there's a reason why I wanted David here on the stage.
Okay.
So I'm in the middle of a design. It's a voice-based design. There's voice stuff in it. David, I thought was a really nice thing of your infrastructure is that digital channel that you have that parallels the voice, that allows you to tap into it for other things. That's a great example of being able to take operationally voice stuff and grab it digitally and then use it as a storage thing to be able to debug it later on. So that's a very nice feature. But again, the reason why it's nice and it works is because you capture it digitally and you can use it in a typical web log stream. Works perfectly.
Oh, excellent. Okay, thank you very much. And by the way, I'm going to, since David didn't do it, I'm going to shamelessly plug also that Telnyx has a booth right as you walk in the door, immediately to your right, and they were giving out this great swag if you travel overseas. They got this. Okay, anyway, check it out. All right. Now I'm going to put in some more gobbledygook. All right, here's your chance. Anybody wants to flee, please, now's your time.
Turn around.
I'm turning around. I'm
He's
not
closing his
watching.
eyes.
Actually, I realize this talk isn't for
He's
everybody.
bad with faces. He won't remember that you ran out.
Oh, what are you talking about? That's why I have the video recording now. Okay, so I'm going to show you some more gobbledygook. Here's some more gobbledygook. Here's a different kind of problem. I actually went in to take advantage of Splunk and the way it works. By the way, you can't do this on Kibana, as far as I can tell. We'll get to that in a moment. The free open source stuff like that, some of it just does not measure up. So here's the thing. Did the leg fail or did it connect? And then I say, and I just type in, make me a chart, 15 minutes count by stage. And this is what it looks like. I'm going to show you a disaster, because you don't have to see the details. You see the disaster where all of a sudden the blue line hits the bottom and the yellow line goes to the top?
Tragic.
Yellow line are failures. So this was a problem back in February where we just, the system just crashed. That was it. I mean, that's all I can say about it. So this represents two problems, and which we'll talk about. And so problem number one is the ability to, once again, integrate debugging into your program and get visualization and trade that visualization around. My brother-in-law once commented, my son-in-law once commented to me that USB technology is the only technology that he knows of where you have to plug in everything twice. Once one direction, once the other direction. You know what? I don't care. Okay, so I'll get to that in a moment. So on the one hand, you got this this issue here of can I put debugging statements into it somewhere in the system and get that feedback around, or is that the wrong approach entirely? Am I being too limited? And the other thing is, by the way, it takes a while for people to notice the system is not running sometimes, okay? Because I actually had something there to check this and to check that, but there are these alarms that go off, and sometimes they false. Anyway, there's actually alarms that go off, and what it does is it says it's constantly, system A is constantly feeding the list of successes and failures, not derived from that same thing, but from some other measure, right? And there's another system that says the call failure rate, there were more than 10 attempts, and it was, the error rate is over something. It says, bam, send out an email message. In fact, hit everybody's pagers. The system is down. Revenue is now at 0. Not only is revenue at 0, people are angry at us. So I'm going to ask about how to do both of those things. How do I get specific debugging in there to let me do that kind of graph? And I'm also going to ask, how do I put in alarms? Now I know David's network is perfect and never has any trouble. I mean, I have a vendor. By the way, that error was not my error. That error was the vendor. The guy who I send my calls to, he was having trouble that day, okay, which has made it even harder to find. So I was able to detect his error, and let me put it this way, sometimes I think they sort of think of me as external QA, okay? So I'm going to ask, how do I put in debugging statements in my code, which will let me do that kind of graph, which I look at every day, along with 40 other graphs, literally. And how do I get alarms and things like that into a system which is distributed across multiple networks and bring them back in a way that's sensible, so I can tell my team, this is not working. Credit cards are failing. Calls are not going out. We're not getting any inbound calls. The web interface went down, okay? All right, so I think I asked you first last time. I'm going to ask Mr. Howe this time first.
Okay, great. So I'm going to point out two things here. One of the things that makes voice really interesting as a medium to work for makes it really difficult to work in terms of debugging, because it's split up into two parts. There's the control part, which is please start ringing and please stop ringing, and the bearer part, the actual voice itself. Now, you handle them very differently, and one is trivial, and that's the control part. How many phone calls did I get? How long did they last? I had 100 phone calls in the last hour, but they only lasted 10 seconds each. What does that mean? It means the voice isn't working, right? And those sorts of, that control stuff is easily stuck into the control streams. Well, here's where it's hard. It's really hard when you have artifacts. When you say, okay, I get crackling on my line, or I get the weird robot thing, which I think is actually pretty cool. And I don't get super upset with the robot thing. I kind of lean into that one.
Right, okay.
Normally because I'm bored.
Yeah, I understand entirely.
Okay,
The customers don't really like it that
However, just think of the technical problem of it, though. How would you actually take a piece of software to go and say, all right, what is the distortion on this voice channel? How would you do that? Well, I can guarantee you that there's no way a web tech company is ever doing that. Just in no way, shape, or form. Because first of all, it's hard. Second of all, it's not high value for them. And third of all, it's hard. So they ain't doing that. So when you think about distributed systems, I think there's a real role, and there's a couple of vendors here on the floor I saw, but there's a real role for being able to take voice and then analyze voice in such a way that allows you to know what the quality of it was through it. And I don't mean, and today it means quality in terms of like pops and robots and stuff. One day, these quality calls will also be around sentiment. For instance, boy, look at all the angry phone calls that are starting to happen. How did that happen, right? And why is this agent making customers angry? Because the sentiment scores on his phone calls seem to be kind of crappy. Right? So two things. The first thing, control channel, easy to do, logging, fine. On the bearer channel, I think there's a lot of good work to be done here, especially in terms of sentiment analysis, emotion, and in terms of voice quality.
Right. By the way, I made up a word called thinometrics.
What?
Out of the Greek, thinometrics. For
Thinometric.
the measurement of emotion.
The measurement of emotion?
Yes. So there's now a word for it.
Does thino mean emotion?
Yes.
Huh.
There you go.
Well, there you go.
Okay.
So I'm going to agree with one thing Moshe said and then disagree with two things that he said. Our swag game is on point, so please do stop by our booth. We have great international adapters, socks, and power banks. Top
Wait, you have
notch.
power banks?
And power banks.
Oh, awesome.
We actually have a Chinese speaker on our team that we literally fly to China and have him essentially run an RFP on the ground.
Okay, by the way, these guys filled a lifetime ambition of mine, because I would go to these conferences and they give out shirts and shirts and shirts. And one day I said, how about like pajamas or socks or underwear or something, other than T-shirts? And they have socks, okay? So this is a lifelong dream of mine. Go ahead.
Why does it take socks?
It was just pragmatic. We tend to be pragmatic. People like socks. They wear them all the time, and
Yeah.
That's true.
Whereas with a T-shirt, it's like they feel like they're repping you. With socks, it's just convenient.
Okay,
And they're actually really good. They don't shrink. They're solid socks. Okay, so two things that I'm going to disagree with Moshe on are first, with regard to Splunk. Splunk is great, but it's also incredibly expensive. We leverage an open source system called Graylog. So shout out to the Graylog folks. They've done a tremendous job in terms of creating an open source system that scales really well in the cloud. The second thing is, well, actually, don't really remember. What was the other statement you made?
I didn't say anything.
Yeah, never mind. Okay, so
I was
in
talking
terms
about
of addressing,
the ability to alarm and things like that.
oh yeah,
Right.
fair enough. So let's talk about sort of alarming and how you track that in sort of in a modern architecture. What I would recommend, folks, if you haven't had the opportunity to read the Google SRE book, it covers this topic really well. So it talks about the idea of having golden signals. So golden signals really are the number of requests that you have, the number of failures that you have, what the error rate is, and the latency of your requests. And by monitoring those sort of golden signals, you can have a really good idea of what system health looks like. From an alerting standpoint, we leverage Prometheus, which is sort of a modern system that allows you to capture time series data. And then in addition to Prometheus, we use OpsGenie, which is a competitor to PagerDuty for the actual notification of folks that are on call. In terms of, just to respond to Mr. Howe's sort of...
We can call him Thomas.
Thomas?
Yeah. It's okay.
Yeah. Thomas's commentary on the complexity of voice and web folks not really doing a good job there. I would tend to agree with him. In fact, to sort of draw the distinction between a company like Telnyx and a company like Twilio, the idea is a lot of the folks that you've seen that have built these really flashy, well-marketed CPaaS platforms have done so in a way that mirrors web tech. And web tech does web really well. It doesn't necessarily do real-time communications well. And so why don't we quickly have a little aside as to why that is, and then sort of what you can do to counteract that. So in terms of TCP, which is ultimately what the vast majority of what you do on a computer. In terms
So
of
TCP is the background communications protocol that you don't see.
That's right. So most things use TCP. TCP essentially deals with the fact that the internet is a system that has no guarantees. In terms of getting a packet from one place to another place, you sort of send it over with the hope that it'll get there, and if it doesn't, then you send the packet again, and you have a triple handshake that ensures that that packet ultimately gets there. And that works really well for web technologies, right? When you're loading a web page, if part of the web page is missing or gets lost along the way because a router is full, then sure, it'll get resent, and eventually that page will load. It doesn't work that way with voice. And why is that? Because voice happens in real time. So you can have little adjustments there for jitter, a jitter buffer, or you can send the packets multiple times to ensure that at least one of them gets to the destination.
Pardon me, a jitter buffer means that I send a lot of packets and I sort of store them up and try to send them in advance of when they're going to be needed, a little bit faster than you can hear them. And then I pull them out of the buffer, and that helps me reduce. Hi, it's Moshe. Moshe. You don't get that. Sorry.
Yeah.
I'm sorry to interrupt.
Yeah, no, totally fine. I'm glad that you're, two things, like there's no guarantee that your packet will actually get there, i.e. packet loss, right? Or two, the packets may arrive out of order, hence jitter. So there are obviously mechanisms that are used to sort of counteract that, but ultimately, what you're relying on is the quality of the network of the provider that you're leveraging, right? And so with the vast majority of customer to vendor interfaces happening over the public internet, unless your provider has control over their network, like Telnyx, then ultimately you're relying on that provider's network. So in the case of Twilio, exclusively AWS. And so there are noisy neighbor problems that you bump into, and if you're trying to deliver an enterprise-grade experience, you may not have one because ultimately your provider's network is only as good as their underlying provider. So what are things that you can do to sort of measure that without having to consume all the RTP, and the RTP being the actual audio that's being sent? You can leverage RTCP. So RT-CP will allow you to actually get information as to the delivery of your RTP packets and give you an indication of the quality. And so you can typically use that in direct SIP interactions. So if you have a phone system and a VIA or a Sonos SBC or whatever it may be, and you can be sort of looking at that part of it. But if you're using the interface over WebRTC, typically that's also SIP backed, and you can use RTCP there as well. One more plug for Telnyx. In addition to providing RTCP on all calls, we also include that information in the CDRs. So after a call
detail records.
Yeah. After the call is complete, you can actually go into the CDRs and check for example, the MOS score to get an indication of what the quality of the call is.
All right, so can I, for example, here's something that I do every day, not personally, I set up a cron job to do it. I have a SIP provider, unfortunately not Telnyx, and what happens is I download the call detail record of every single call. That includes what number called which number, how long it called, where the call was routed through, which carrier actually carried the call, the duration of the call, how much I was charged, and all that information. It all goes into my database. Once again, I have the ability, and that actually goes in a different database, not in the same one, but if I have a problem and I look at the call and I say, I'm looking up this call and this call and this call, and I bring up the web page that displays on a curl, you know what happened, and it's in there, it's populated. And all of a sudden I notice that all the calls to Australia that go through a particular carrier are going bad. And I give, my provider a certain amount of time, and I say, you know what, from now on we're not using that carrier. So I won't tell you the name of the carrier, but that carrier is no longer, I don't use that carrier for international. First, I had a problem in the UK, and I cut them out of the UK, and then I cut them out of Australia, and then I come. So do I get this kind of call detail record integrated into something, or in integratable ways that says, when I bring up a particular problem call, I can integrate that information into my system. So is that, how do you provide it? Do you provide it on a daily basis, downloadable basis? I can download the whole record. That's what I can do with the other guy.
It's available instantly, right?
It's available instantly,
so
right?
As soon as a call is complete, we cut the record, and ultimately a good way, just sort of a trick of the trade, I guess, to share with folks if you're trying to get some insight into who's doing a good job or who's not doing a good job, is you can sort of look at really three metrics from a call detail record perspective. Your first metric is PDD, so post dial delay. So how long after you send the invite are you going to get 183 ringing back, saying that the call is actually on its way there? The second one to look at is ASR. This one can be a little bit tricky at times in the case that your users are dialing bad numbers. You may end up having a low ASR, and you can use an NER, which ignores those calls.
You have to define ASR and NER.
Yep. ASR being average seizure ratio, because you used to seize the line back in the day, and NER being... Yeah. Yeah, I think it was an unfortunate way to describe. Or NER, network effectiveness ratio. And then the third is ACD, so average call duration. So usually, even if you don't have RTCP, if you don't have any indication of what's going on in terms of the actual RTP packets, if your users are on phone calls for 10 seconds, it's indicative of a problem, right? Because usually folks are talking for longer than 10 seconds. So you can sort of use those statistics in your current environments to make a determination on what's working and what isn't.
Yeah, excellent, thank you. And by the way, it's also something to bear in mind. I think we have 128 inbound 800 numbers. And what happens is every once in a while somebody hits that 800 number incorrectly. All right, or whatever it is, or they hit us, they somehow manage to get to us anyway. So we actually do get a fair number of calls where, they dialed us and they hang up, and you have to be able to determine. Give me a second here. I'm just getting a little dry. By the way, in case you're wondering why speakers have bottles of water and you have pitchers, it's because this is actually fairly decent vodka they give out to the speakers now. So, Thomas, would you care to comment also on the same topic? Not that I remember what the question was anymore. I was asking about, all right, go ahead. You remember what the question was, right? David, what was the question precisely? I don't remember.
We're all forgetting questions. And,
okay, fine.
But no, I do remember. The question was with regard to calls So being able to identify, for example, a problematic carrier
Right.
when making a phone call. And sort
Right.
of
So what do I do and how, see, remember, there's a question of, David is describing in part the data that is made available by David. But then I also need a solution so that I can make sense of it. It doesn't do me any good to have this data if I can't integrate it with other data. Sometimes it's something that, like I said, I integrate into the web page because that's where it makes the most sense. Sometimes I go to the raw files and look through them and find all these issues. So Thomas, if you can address both of these from a perspective.
For sure. So what I think is really fascinating here, and I'll point back, is the whole idea of golden metrics. And I want to expand that idea just for a quick second. So as voice engineers, we can tell you that, if call durations are 10 seconds, you can't have a conversation in 10 seconds, right? That can't be good. Alternatives would be in messaging. No human being can send 10 text messages a minute. If a phone number is sending 10 text messages a minute, guaranteed it's not a person doing it. Something else bad has happened. And now, let me just jump up on that idea just for a quick second. So again, the whole point behind what we're trying to convey here is that to keep these systems up and running is becoming a time and place where it's more than just one medium, it's more than just one thing. So one of the things I think you have to own up to as you design your systems and run them is that you may have your own golden metrics. You may have things that you're going to be monitoring which might on a voice thing make some sense, but might not make any sort of sense from a business logic level. And I'll just make one example of that. If you are, one of the big issues of telephony in general is fraud. Fraud's a big deal.
Fraud is an incredible deal.
Fraud, right? We talked a little bit about that and our issues with robocalls. So imagine that in your particular market, we'll say it's financial, that the actual signatures of the calls make a lot of difference, and the rates of the calls make a lot of difference. I shouldn't have 15 phone calls from the same cell phone in the last hour. That doesn't make a lot of sense. That doesn't make a lot of sense to me, and it's a fraud flag. So one of the things I'm going to encourage you to do is when you start putting up your dashboards, make sure that the business rules and logics that you can use are over and above that which you get from your voice vendor. So, and I'll just couple more examples. Not only can you have too many phone calls from the same number, but international calls. You've got double calls. I called once and called yet again. That happens a lot. So one of the real wide sweeps of what's happening in our industry is it used to be that only one of us or only one vendor would provide your solution. In no way is that going to be true, and it's becoming less true over time. So business logic belongs to you now, and you instrument that.
Right. I'm gonna say a few words about. First of all, I wanted to close on that, but I decided I want to say a few words anyway. Also on the topic of fraud, I'm going to do some shameless self-promotion. If you look online, there's a conference called CluCon, C-L-U-C-O-N, and they run a webinar. And I gave a webinar a while back on how to use open source software to defend your system. And I became interested in this when it wasn't that they were actually making fraudulent calls. They were overwhelming our system with attempts to make fraudulent calls, to the point where the software takes the thing, looks at the message and says, okay, I can try doing that, and because it's a valid inbound message, matches it against the system and says, that's ridiculous, and sends back a message saying, forget about it. Well, it just overwhelmed our system. We were running out of, we couldn't make legitimate calls because we were getting 300 calls, simultaneous calls, and we didn't have any licenses left to make more calls. It was preposterous. So that's something else to bear in mind. I just want to emphasize what Mr. Howe said. All right. We have about a few more minutes. The vodka hasn't kicked in yet. So I wanted to ask if there are any questions from, first of all, would you please thank these fine gentlemen for their work? Okay. And I'm going to entertain questions from the audience, other than where's the lunchroom, which is right behind. Okay, we're clearly standing between you and lunch. Going once, going twice. I'll stick around for a few minutes in case anybody have any questions. Thank you very much.